All right, Isaiah, let's take a look at lesson number 35, angles and polygons. Let's look at that first. We've kind of gone over this before, but let's review over it. The sum of any polygon, the angles on the outside, always adds up to 360 degrees. So let's write 360 over here. And now we're just going to list all the exterior angles. Let's not put y, because y is interior, just the exterior, okay? So we have x plus 55 plus 80 plus 40 plus 50 plus 65 equals 360, okay? X plus x is 2x. When I combine all of the other numbers on the outside, I'll have 290. So 290 equals 360. All right, so again, I took this exterior angle plus this, plus this, plus this, plus this, plus this, equals 360, because that's the truth of the circle, the sum of the angles. X plus x is 2x. These numbers combined was 290. I'm going to subtract 290 from both sides. 2x equals 1970. Okay? Divide both sides by 2. X equals 35. All right? So let's write that over here. X equals 35. So now let's draw attention to right here. If this is my angle right here, and I know that x is 35, 35 plus 55, when I substitute the value in, is 90 degrees. So if this side is 90 degrees, what does the y equal? The y equals 90 degrees also, because x plus y equals 180 degrees. Okay, on that straight line. Okay, let's move on from our angles and polygons to what was kind of causing us problems, 35.b, inscribed quadrilaterals. Inscribed quadrilaterals. Yeah, say that. Okay, let's take a look at their formula. All right, so we remember what the inscribed angle is. Let's take a look at 35.2. 35.2. Look at that perfect circle. I know, pretty good. Down here, across, up, and over again. All right, so they're going to have z degrees, 75 degrees, a degrees, y degrees, and x degrees. Okay? Oh, yeah, let's do 80 degrees. There you go, makes more sense. Okay, so now I'm going to look, they also have 50 degrees also over here. So if I am looking, the first thing I want me to solve for is x, okay? So I'll solve for x, y, and z, and they're starting to solve for what z is, okay? So if I look from z to z here, I can also know that there's nothing really that comes down to that corner, okay? But if I include the 50, from this point to this point, I know that z plus 50, z plus 50, equals 2 times 80. Because remember, if it's 80 degrees right here, by the time it gets to the exterior of the circle, the degrees is going to double. Remember that? Okay? So if it's 80 right here, it's going to be double 80 over here. Okay? All right, so now I'm going to have z plus 50 equals 160. Okay? I'm going to subtract 50 from both sides. Z equals 110. Okay? So z equals 110 degrees. All right, so now that I know that, the next step is I need to figure out what x is. Okay? So, let's see here. If z, x plus 80 equals 180. Let's take a look here. I use the opposite angle, okay? Here to here. X plus 80 equals 180 degrees. That's just a rule. I take the opposite. So this plus the opposite equals 180. So also, y plus the opposite, y plus 75 equals 180. It's just a rule to remember. That's how they solve it, okay? So subtract 80 from both sides. X equals 100. Y equals, subtract 75, 105. Okay? So the first thing to do is, if this isn't large enough, you include what else is there. C plus 50 equals double the opposite angle. Okay? And then this plus this equals 180. This plus this equals 180. Okay? So that is the second set, inscribed quadrilaterals. Now let's talk about fractional exponents. Fractional exponents. Okay? Let's erase this. Right, fractional exponents. Negative 27 to the negative 1/3 power. Okay? So the first thing I'm going to do is I need to not have a negative exponent. So I'm going to write negative 27, and I am going to write that as a denominator, okay, with now a positive 1/3. A positive 1/3. So it was this as a numerator. Now by bringing this below, I change the power of my exponent. I have negative fraction line 27 1/3. Okay? And now what I'm asking myself is, what number times itself? It's basically saying, what's the cube root of 27? Okay? So what number times itself? 3 times is 27. That answer is 3. 3 times 9 is, 3 times 3 is 9, times 3 is 27. So my answer is negative, because there's still a 1 up there, 1/3. Negative 1/3. That negative from the 27 carries here and carries back over to there. Okay? We covered this before. Let's try 35.6 one more time. 35.6. All right, I've got negative 8. Negative 8 to the negative 2/3 power. Okay? So the first thing I need to do, realizing that's all over 1, I'm going to change it and write negative fraction line 8 2/3 with a 1 over it. Okay? All right, so what they're going to do further is they're going to change 8 2/3. They're going to change it to negative 1 over 8, and it's going to be 1/3 in parentheses squared. Because the 2 over 1 times the 1 over 3 gives you the 2/3. They're further expanding it. Okay? So now they're going to say, now they're going to have you answer, what is the cube root of 8? So what number times itself 3 times? What times what is 8? And that answer, of course, is 2. So I've got negative 1/2 in parentheses squared. Okay, because I solved inside the parentheses. Now, negative 1/2 squared is going to be negative 1/4. And that is their answer. Okay? You've done practice already A and B before. You can try C, D, and E. The practice answers are in the back. But when you get to letter 19, if you need help, reach out. I'm here to help. Okay, that's lesson number 35. One of those difficult ones. Okay?